Hello everyone. So today we're going to start with the last chapter of your software engineering course, and that is going to be software project management. So we're just going to I'm going to introduce the software project management to you. Although this is a part of a larger course, you have an entire course on software project management, but this chapter that we're going to do here is just going to give you an introduction to what exactly is studied in software project management and what are the activities which are actually performed. Right, so this is going to be the end of your course on software engineering for you. So if you are interested in learning more about software project management, then you can further take this as an elective and can probably get into the details of it. So what we're going to learn today is what is software project management all about. So we have looked that we have seen that the SRS, there is a different phases of software development life cycle. We have different phases, we have different models, and we have learned about the different phases. Now this entire development of software from the initial stages right till the end of your development to maintenance is managed by a person who is called as a project manager. Now the role of a project manager is to take the ownership of this entire development activities and deliver this to the client, right? So as a part of the project management role, he has to perform a lot of activities. So we are just going to get into some of the activities that he performs, right, and have an idea about the roles of a software project manager, right? So one of the most important aspects of software project management is to learn how to manage a project, and one of the main causes of projects failing is due to people or managers not able to manage the project well. Okay, so it's important to learn different aspects of software project management. Now as a fresher, you don't normally get into the role of a software project manager because this requires a lot of experience. This requires you to work with all the different phases of SDLC, and then only you can get into a role. So this is more like a senior role for this domain, right? So this software project management is basically a senior role that is performed by a project manager. Now this basically the project manager is basically the captain of the ship. Okay, so he's the one who's going to get all the resources, plan everything, try to make sure that we stick to the deadlines. He's the one who's going to talk to the client, right? So these are some of the responsibility of project managers. So they start with the project proposal writing. So this basically is the initial stage in which they work. So even before the project is committed by the client, the process of writing the proposal, process of estimating how much it's going to cost and what's going to be the profit in that particular project, how the profits have to be aligned to the organizational objectives. All that has to be managed by the project manager. Along with that, he also does all the scheduling. That means what resources are required. He also makes a plan for project staffing. That means who are the team members who are going to be working on that project, what are the different people, what kind of people with what kind of expertise is required in the project. All that is his cup of tea. After the project takes off, that means when the project starts running and people start working in the project, he also has to monitor and control everything, whether everything is on schedule, on time, there are no risks, there are no problems happening in the project, that all the people who are working are working in sync without any issues. They're all doing the tasks as per the assigned timelines. Other than that, he also has to manage all the software configuration, which means all the files, all the source files. Suppose you have a file which is being worked upon 5 times, 10 times. So you have different versions of those files. So software project manager, the project manager's role is also to manage the various versions of a file, how those files are going to be deployed, how is the folder structure, how those files are kept, who is working on those files. So he basically has an ownership on the entire thing. He's also a person who is responsible for managing the risks of a project. So if somebody is going on a sudden leave due to some calamity or some problems or some personal issues, then the project encounters risk, right? So he will have to plan that. He'll have to manage those risks. If there is an issue wherein he's not able to find a particular resource which is required for the project, then that's a risk. So he has to manage that risk. So there is a complex process of how you manage risks. You have to have a risk assessment plan. You need to have a risk mitigation plan. So that's a complex set of activities by itself. Other than that, the project manager is also responsible for making all the presentations, having discussions with the client, making reports, writing reports, and all kinds of data chart that he has to show to the customer, right, on a regular basis. So basically the project manager acts as like a single point of contact for the company as well as for the client side. So if the client has any issues with the way things are going, the project manager is the person they connect to. Okay, so you see there are so many responsibilities, and they are all very important of a project manager. Now what happens is the project manager's activities are mainly classified into two activities. Okay, one is project planning and other one is project monitoring and control. Now this project monitoring and control only comes into the picture when your project starts, right? But before the project starts, the entire planning of the project is done. Right. Now in that planning we talk about the feasibility study and the requirement analysis, and all that stuff goes in project planning. Once the development phase starts, then the project monitoring and control activities are carried out. Okay, so when you talk about project planning, what are the different activities which are associated with project planning? The first one is estimation. This is a very important activity, because before the project starts, we need to find out the effort, the cost, the resources that are required, and what is going to be the duration of the project. And all this is going to come under the estimates. Then you also have project scheduling, because when you talk about duration, then you'll have to worry about the scheduling as to when. Basically, project scheduling is basically about setting timelines for different activities which are going to be a part of that project. Then you will also have to worry about the staffing plans. That means which resource is going to be required at what point of time, because say we need a person who is a test engineer. Now this person is not required at the beginning of the project, but he has to come in when the coding phase is almost about to get over, right? So he has to plan which resources are required in the project. So those are all a part of your staffing plans. Now these are all plans which are made before the project takes off. Okay, before the project actually starts. These are all part of project planning activities. Then another important activity which is associated with project planning is risk handling. In this case, the project manager identifies and analyzes all the risks which are basically a part of the project. For example, it could be related to a resource, it could be related to technology, it could be related to for example, a simple thing like if there is some strike which is happening very often in that city, or there's a natural calamity which is happening due to which the offices have to be shut. All those are a part of the risks. If somebody is going for a long vacation, if one of the key resource is going to go for a long vacation for getting married or something like that, that's also a part of the risk. So he has to identify all that from before. And then there are some other miscellaneous plans like quality assurance, configuration management. This configuration management is related to the software configuration management, where I told you about licenses and versioning and all that. Quality assurance plans is basically you are assessed. So on a regular basis, the audit team, there's a quality audit team in all the organizations, and they come and check whether you're following the proper processes or not that is required for a good company. So they come with some set of guidelines and they will come and audit what you are doing. So the project manager also has to make quality assurance plans so that all the processes that he is following is as per the rules and regulations of the company, which the company has set. Okay, so these are the list of project planning activities. Now this has to be done in a very, very careful way. You cannot just plan in a very ad hoc way, right? Because if you don't have a proper plan, you will have unrealistic timelines, right? And this is a absolutely no for a project manager or for a project, because unrealistic time is going to create all these issues that you see here, right? For example, you will not know when exactly your project is going to get over. So you would probably set up a, you would probably give a date to the client which is going to be a judgmental date, because it's not going to be a date which has been planned properly and has been given after analysis and proper planning. So what is that going to do? It's going to have delays, the customer is going to be dissatisfied, the team is going to be under stress all the time, the quality of work is not going to be good, and finally there are chances that the project would fail. Okay, so project planning requires a lot of attention, a lot of care. It has to be done in a very, very good way, and there are a lot of tools and softwares available today which will help you in doing the project planning. Okay, so there is a tool called Microsoft Project Plan, MPP. That's a very useful tool and a very common tool which is used by all the project managers today, most of them. All right, now when we talk about project planning, there has to be a document in which all the plans that we talked about has to be put together. Now once the planning is done, the software project manager basically puts all that plan in a single document, which is a very important document in software industry, and that document is called as a software project management plan document, which is very commonly known as SPMP document. Okay, so SPMP document is basically a document which consists of all the plans that the project manager has to do. And let's look at the structure of it. How does an SPMP document look like? What's going to be the structure? So it should start with an introduction, and in the introduction you would have the objectives, what are the functions of the project, what are the performance issues, management technical constraints, and all these are basically the criteria which has to be put inside this heading of introduction. Then comes estimates. Estimates will have again you have to give basically the details of how you have done the estimation, what techniques have you used. You just can't write $10,000. You have to actually kind of write a detail about how you have arrived at that number, what method did you choose in order to get to that estimate. Other than that, you also have project resource plan. This will tell you about the softwares, the people who are going to be a part of it, what is going to be the hardware plan, what softwares you'll require, is there any specific kind of a resource that you need which is rare. So all that will go in your project resource plan. So these are all a part of, basically these are all you can call like heading of each chapters of your SPMP document. Then you have schedules. Schedules basically is one of the very important kind of content in a SPMP document. The schedule basically gives you a breakdown of all the activities that are to be performed in implementing or making that project, right? And you also have basically a lot of diagrams and representations of when exactly each of those activities need to be performed, what are the timelines, and all of them are part of the schedules. Then you also have a risk mitigation plan, which involves the risk analysis, the risk identification, risk estimation, risk mitigation, all the plan A, plan B, everything is there as a part of risk management plan. Then you also have project tracking and control plan, and finally the miscellaneous plan, which has basically things related to quality assurance and what are the tailoring means. Suppose you're using a model, right? So you don't use every bit of that model, so you basically customize it according to your needs. So tailoring means customizing something depending on what is your requirement. Okay, so process tailoring means you have a process which is already defined, but how you have used it for your project. So what are you doing? What are the parts that you're using and what are the parts you're not using? So all that has to be put inside the miscellaneous plan. Okay, so this is basically how your SPMP document is organized. and this is basically the Bible of a project manager. The project manager basically takes a lot of time to prepare this SPMP document, because this is a document which is going to be used across the timelines when he is actually monitoring and making this project, and this has to be put together into a tool. For example, like I told you about Microsoft Project Plan, so all these in Microsoft Project Plan you have various options by which you can fit this SPMP document, and you can do all the estimations and tracking and controlling and everything there. Okay, now there are a lot of things to study here. In fact, an entire course is required to study each and everything which is mentioned here. But what we'll just take up a little bit is we will look at some of the estimation techniques, because sometimes they are asked in interviews and placements. Although this is not going to be asked in your placements or in interviews, because this is not a very this is a very specialized chapter, like specialized course, software project management. It's a 1 semester course by itself, so normally they don't ask you, but in case they ask you about estimations, then it's good to know a little bit about effort, cost, and all these terms, right? So let's look at some of the software cost estimation methods and how they do it. So first important thing is you need to find the size of the product. So the cost estimation, the basic way of estimating the cost of your software is to find out the size of the product. Once you have the size, you can find out the effort which is required, right? And from the effort, you can determine the duration and the cost. So for example, let's say that I have 10 lines of code, or let's say I have 1,000. So I have identified the size of my project as 1,000 lines of code. Now, for 1,000 lines of code, what is the effort required? So effort is going to be in terms of hours, right? So let's say that I will require around 20 hours to write 1,000 lines of code. Okay, so now if I have 20 hours, that's what I have estimated to write that 1,000 lines of code. Now, how do I set the duration? So duration is set, say like if I spend 5 hours a day. Normally in the IT industry, the timelines are set for 8 hours a day. So say I, invest 5 hours a day, to kind of make this project or implement this project. What is going to be my project duration? So my project duration is going to be 4 days, right? So I can implement this project in 4 days, because 5 hours a day into 4 days is going to be 20 hours, which is the effort required. So the project duration is going to be 4 days. Now how do you find the cost? The cost is found out by basically multiplying a factor with the number of hours required. So let's say I require 20 hours effort, and per hour if I am going to charge, let's say $50, okay, I'm going to charge $50, then what is going to be my cost of this entire software that I'm going to charge the client? So the cost is going to be $1,000. So this is how, like, roughly you can find out the cost of a software. I hope you are able to understand this. In case you have any doubts, you can always reach out to me. Please send me a message and I can explain this once again. So this is just a brief way by which you can find out the cost of a software. Alright, now there are different techniques of finding the cost. So this is a very graphical representation of whatever I discussed. So once you find the size, from the size you can find the effort and you can find the duration. Okay, and from the effort you can find the cost, because whatever is your effort, like say 8 hours, then you can multiply per hour effort and then you can get the cost. Now once you have the effort and you have the duration, then what is the staff, how much of staff, the estimation for staff will be found out from there. For example, let's say my duration is let's say my effort is, let's say 80 hours. Okay, this is the effort I've got, and the client wants this to be done in say 10 days. Okay, so 10 days. So if one person works for 8 hours a day, he can do it easily. So in my staffing estimation, I just need one person. But say the client, we have arrived at, the client says 10 days is too much and I need to actually do it in 5 days. So depending on the number of the duration of the project, now my staffing estimation will change. So now I will need 2 people who can work for 8 hours a day. right? So 2 people working for 8 hours a day, that means they are working for 16 hours a day, and now if they work for 5 days, I should be able to complete the project in 5 days. Okay, so depending on the effort and the duration that is set by the client, right, the staffing information is basically found out. How many people do I need? Do I need a team of 10 people, or team of 5 people is enough, right? So that's basically how things work out. Now once I have the duration and once I have all the people in the team, that means whoever the staff which are which are going to be a part of the project, then I can schedule the tasks and the work and the activities for each one of them. So basically, in order to schedule the tasks for the staff, for the people who are going to work in the project, for all the team members, I need the actual duration and I need the number of people. So from the staffing information and the duration estimation, I can get the schedule for the staff. That means I can tell this person has to finish this work on this day, this work on this day, this work on this day. And because I need to complete everything in 5 days, so this person has to complete this piece of work today, this piece of work today, this piece of work today, this piece of work today. So I can make a nice schedule for that person. Okay, so this is basically a rough way, in a generalized way, of how you can make schedules and you can find the cost of a project. So basically the cost is derived from the effort. Okay, effort can be derived from the size, and the cost can be directly taken from the effort. So you effort 8 hours per hour. If you have $50, you know the cost $400, as simple as that. Okay, so this is a graphical way of how you can estimate the cost and also schedule or plan for the activities for the different staff in the team. Now there are different ways by which you can estimate the cost of a software. The one which we just saw right now, which we were discussing, was based on the size, and the size is normally calculated by lines of code. Okay, but there are 3 different other ways. There are different ways by which we can estimate. Now one of the ways is called as empirical technique. Okay, in empirical technique, what happens is you have an educated guess based on a past experience. So for example, if you've made a project, like if you're an experienced person and you've been making a project for, like, you have implemented 10 projects and you find that the 11th project is almost the same as the other 10. So what you can do is you can take an educated guess. Okay, you can take an educated guess. So you say, like, okay, that project costed around $20,000, almost the same, the scope is little less, so we can probably do it in $15,000. So that's basically called as an empirical technique by which we make a guess based on the past experience. Now in order to do this, you need to have people who have done those kind of projects before and they're experienced in this field. Okay, so you have expert judgment and Delphi estimation. These are examples of empirical techniques by which you can find the cost of a software. The second one is heuristic. In heuristic, you basically have some kind of mathematical equation where you can put in the data and get a cost, something like that. Okay, so in this case, whenever you talk about heuristic, we talk about quantifying your whatever you are trying to quantify on the basis of a mathematical expression or a formula. So in a heuristic technique, we use a mathematical formula, right? And using that formula, we add in the parameters that are required there, and whatever you get as an output, using that, you can find out the cost of the project. Now this is an example of your heuristic estimation technique. That is called as basic Cocomo model. I'll just tell you a brief about what that is later on. And the third one is an analytical technique in which you basically find out the cost by simple assumptions. Okay, now this is not very commonly used. Most of the time we use these two, empirical and heuristic techniques, to find out the cost. But analytical techniques are basically used when you basically have certain assumptions. Assumptions could be anything, like for example, you can say that this function, if it is of these functions which accept 3 parameters, will take 2 days to implement. So something like, you assume that, okay, a function, how can you say that a function is complex? So we can say that any function which accepts more than 3 parameters can be categorized as a complex function. So you basically assume it, okay, and by assumptions you come to a estimate of what your software is going to be costing. Okay, so Halstead is Halstead technique is a way by which you can find the cost by using the analytical technique. Now, in order to find the size of the software, okay, lines of code is the most commonly used parameter. Okay, and when you're finding out the lines of code, we should not calculate the comments, that internal documentation, and any blank line. So if you are like writing a code where you're leaving some space and writing a code, you should not add these as lines of code. Or if you're writing some comments, these comments should not be added as lines of code. So that's an important point. Now, the disadvantage of using lines of code is that size of the code can vary with coding style. Now, if I am a very good developer, I can write a very sophisticated program in very simple ways by writing 5 lines of code. And there is some other person who is not a very good programmer, and he cannot write simple codes, and to implement the same problem, if he's using around 20 lines of code, right? Now, what's happening here is I should be getting charged. I should be able to charge the customer more because of my talent, because of my skill, because I am highly skilled than the other person, because I'm implementing the same problem in just fewer lines of code, whereas the other guy who's not a very skilled guy, but he's he takes more lines of code to implement the same, but according to the lines of code metric, he is going to get paid more, right? But that's not the right way of looking at this. So this is one of the disadvantage. The size can vary with the coding style, and it focuses on coding activities alone. Okay, you don't look at the quality of the code, you don't look at how the code is efficient, whether it's been done by a very skilled person or the code has been written in a simple way. All that is basically not kind of taken into consideration. So if I use some good programming practices like reusability or library functions, right, then that is basically a disadvantage for me, because I'll be paid less and less. Okay, so it basically kind of penalizes higher level programming languages, like where suppose you're using object oriented programming, where you can easily kind of extend a functionality or reuse a functionality by kind of just extending a class, then that is basically the better programming is basically leading you to charge less to the customer. So that's a problem with lines of code. Also, it does not address the issue of complexity. Some code can take a lot of time. Some 3 lines of code can take a lot of time because those 3 lines can be very complex. Okay, so that is another problem. So the complexity of the code is not at all taken into consideration here. So that's a very big disadvantage. And just from the problem specification, it's very difficult to estimate the lines of code. Like if I give you a requirement and I tell you, can you tell me how many lines of code this is going to have? That's again another challenge. Okay, because it's going to be difficult for you to find that out. So that's basically the disadvantage of using lines of code. Now, in order to overcome some of the shortcomings of lines of code, we have something called the function point metric. Now, in function point metric, we basically kind of don't look at a single line of code, but we look at the input, output, and the interfaces which are there. So if you have like a set of inputs, like suppose in order to implement one function here, right? So what you do is you take this function and you look at all the inputs which are going into the function, you look at all the outputs which are going into the function, right? And you also look at what are the different interactions of one function with the another function. So if there is a function call happening between objects, now according to this you set up complexities. That means if suppose there are only 4 inputs to a function, or if there are only 2 outputs, which some important data which is coming has only 1 output, right? This is the only data which is coming as an output. Then you can kind of say that this function is not very complex. It's a simple function. So a simple function will have a cost associated with it. Similarly, if your function is complex because it has too many arguments which are going in, the logic is different, it is calling some other functions and all that stuff, right? All this is basically a part of, you know, a complex function. So in this way, we can say that, you know, the complexity of the function is more. So you can put a like kind of a weight, like you can have 1, 2, and the cost is calculated based on what is the complexity of a function. So if your function is simple, we can say that you can charge $10 for it. If your function is basically complex, you can say it will, you know, it will require, say, more hours. Okay, so that way we calculate the cost of the particular software. So rather than looking at a single line of code, we are looking at the complexity of a function here, and we basically, you know, kind of have some parameters by which we can identify whether a function is complex or simple, and then associate an effort based on that. Similarly, you can even look at files. If your program, the number of files it is generating, or the number of files that your program is connecting to, all of that is basically, you know, can also be attributed to the complexity. So the number of files basically means that more number of data are being referred to or being, you know, processed. So that way also you can basically put an estimate or the effort. Even interfaces are basically, you know, like a connection between two systems, right? So interfaces are only used to exchange data. So the number of parameters that you're exchanging can basically you can add a complexity to it. So if you're exchanging just two values, right? If you're sending only two data from one system to another system, we can say that the interface is simple and have a, you know, the effort can be, you know, less. But if your interface is exchanging 10 data, 15 data, or it is exchanging objects, or, you know, then you can associate a higher complex interface and associate an effort which has, you know, more effort. And accordingly, once you get your efforts, you can actually calculate the, you know, the cost. Okay, so this is basically function point metric is a technique by which you can, you know, kind of remove some of the disadvantages of lines of code, and this is more robust, this is more accurate than your lines of code, right? Now the function point metric again has some issues, right? Now the size of the function is considered to be independent of its complexity. Now that's also another point. Like when you look at the size of the function, right, that complexity and the size of function has no relation here. That's another point. Okay, so for that case, you could have basically a function which has a complex algorithm that is being implemented there, but that complex algorithm, although it's complex, can be implemented in 5 lines of code. But to write that 5 lines of code, again, it's going to be a lot of analysis is required. So again, there's a simple problem that a function, the complexity of a function, right, is not dependent on the size, because there is no correlation between size and complexity. You can have a, you know, function which is larger in size, having more input parameters, having more output values, but the complexity is low, right? So this is also a problem similar to your, you know, lines of code issue. Now there is an extended function point metric which also adds an extra parameter, and that extra parameter is basically the complexity of the algorithm that that function is basically implementing. So it's just an extension. So function point metric is just an extension of function point, you know, the extended function point is just an extension of function point by, you know, you add in that extra parameters which you are missing out on. So this is not something that you know, is important for you to actually delve into. You just have a basic understanding of what these are, and that should be enough. Okay, now in terms of empirical size estimation techniques that I discussed, we discussed about expert judgment and Delphi estimation, right? Now expert judgment, again, I told you that it's again, you know, a guess which is made by an expert. So, you know, someone who's already worked on those projects and all, they can guess and you know, find out that, okay, because I've done a project similar to this and that costed this much, so approximately this is going to be so and so. Now whenever an individual is making a judgmental decision, obviously there is a biases involved. Now if you have 5 people, you know, judging basically the effort for a particular software, your 5 will be all different. Okay, now that's why where this expert judgment and Delphi estimation comes into the picture. Now in Delphi estimation, what happens is you have different people. It's not just one person who is associated. So there will be a team of experts and there will be a coordinator. The coordinator, will basically coordinate amongst the different experts, but different experts will not be allowed to meet each other and discuss. So they carry out the independent estimation based on the experience and judgment. And after that, what happens is, if they don't match, the coordinator basically kind of connects indirectly without them, talking to each other. They note down some of the, high values or low values, and then he, without naming who is there in that particular team, he shares that information with others, and then they go look at the comments and look at the various estimates that each leader has made, each member of the team has made, and then they re-estimate, and they never get to meet each other. So it's basically, if someone has some bias or he has done estimation properly, but for one part, if there is some problem that he has not estimated it properly because of a personal bias, then using the Delphi estimation technique, that is basically taken care of. Okay, so Delphi estimation is an extension of expert judgment, wherein in expert judgment you can have a person who can get a wrong estimation because of individual bias. So that is corrected by having a team of experts which do not meet, but they carry out independent. It's basically like when we evaluate your projects, we'll have like 3 people who will be looking at the project and evaluating. So 3 of us, will sit differently and give you separate marks. And then those marks are given to a coordinator. The coordinator will look at those 3 marks, and then he will make a decision that, okay, if all the 3 marks are similar, then he knows that, okay, it has been evaluated properly. But if somebody gives you 60, but somebody is giving you 90, so he will ask, why did you give 60? Why did you give 90? And both those comments will be shared amongst the experts. And then they will re-estimate, like saying that, okay, maybe there was a mistake there. So they will re-estimate, and this process will go on until all the 3 experts arrive at almost similar marks. Okay, so this is basically what Delphi estimation is all about. Right, now we have the heuristic model, where you had come across this term as Cocomo, right? Cocomo. The Cocomo, it's an abbreviation. So Cocomo means constructive cost model. Okay, now this was proposed by Boehm. Now in this case, we use a mathematical formula to find out the effort and the cost, right? But in order to fit, you have 3 different formulas, and those 3 different formulas are available for your products which are of different kinds. So you can have an application system, or you can have an utility system, or you can have a embedded system. So depending on what kind of problem you are basically trying to solve and trying to estimate, you have different mathematical formulas for it. So first you have to identify that product or the project that you're doing belongs to which category here, whether it's an organic category, whether it's a semi-detached category, or whether it's an embedded system. Now depending on this, you fit the parameters into a formula, and based on that output, what you get, you can find out the cost and the effort. Okay, so it's very simple. Only challenge is to identify how much of basically which kind of application you're using, and this is based on your lines of code. So you need to find out the approximate lines of code, and you need to find out whether the project or the application or the requirement is that belongs to an organic category, which is an application software, or a semi-detached category, or utility software, or an embedded system. Okay, so let's look at the different formulas. Now when we talk about an application program, we are talking about data processing scientific programs. Okay, like for example, even your online system is like a data processing system. When you talk about online reservation system, those are all data processing. Okay, so any online system, data, for example, your flight booking, train booking, your banking, all those are data processing, and they are considered as application programs. If you are implementing compilers, linkers, editors, they are all utility programs. Like suppose you have notepads, those kind of small file, zipping programs. these softwares are all belong to utility programs, and your operating system and real-time systems, they are part of your system programs. Okay, so most of the time we will be worried about the application programs because you are studying masters in computer applications or master of science, right? So when you're talking about master of science, if you're getting into research field, then you will be talking about utility programs and system programs. But if you're not getting into research and you're going to do basic science or basic applications, or if you're going to go and work in an organization, then mostly you'll be working on application programs. Okay, so let's look at the formulas which are associated with this. Now let's go to the formula straight away. Yes, so the formula is effort is calculated by A1, KLOC is basically the kilo lines of code, to the power, so it's basically you find the kilo lines of code, and to the power A2. And A1 and A2 are basically the constant values which will be given by the different categories. Okay, so you can find the effort first, and after you find the effort, you can also find the total development time. So what is the time taken to develop that particular, what is the time? So basically you get total development, estimation in months. So the values that you get of T, D, E, F is going to be in months, and your effort is going to be in person months. Okay, in terms of person months. So for example, if it says like 10 person months, that means you need 10 people working for 1 month that's going to be the effort. 10 person months means one person working for 8 hours a day, 5 hours a week, he has to work for 1 month. So 10 person months means we need 10 people working 8 hours a day for 5 hours a week, then they will be able to implement this particular the requirement. Okay, so it's very simple. You first have to find the kilo lines of code. That's all. A1 and A2 are constants, and these A1 and A2 are constants for different categories. Like for embedded system, the constant value will be different. For applications, it will be different. For systems, it's going to be different. So let's look at the estimations. So for organic systems, so organic requirements, so those requirements which are organic. Okay, organic means what? If you've forgotten, organic means applications. Applications here, this one. Okay, let's go back again and see. So organic means application. Semi-detached means utility programs, and embedded means system. So I think you can just refer to the PPT which I'll be sharing in case you have any doubt. So for organic or application programs, the effort is calculated by the constant 2.4 into kilo lines of code to the power 1.5, and whatever value comes is going to be in person months. For a semi-detached, like utility programs, okay, semi-detached means utility programs, effort is given by 3 into kilo lines of code to the power 1.12, and for embedded softwares, effort is given by 3.6 into kilo lines of code to the power 1.02. So it's basically 3.6 into, suppose it's 10 kilo lines of code to the power 1.20, and whatever is the number which is going to come is going to be an effort in terms of person months. Okay, so this is the development effort estimation. Now you can also find out how much time it is going to take to make it. So in order to find out the time, you take the effort which you have calculated earlier. So the total development time will come from the effort. So whatever comes here, so whatever person months the value comes here, if you substitute that value into this formula, right, that will give you the total development time. So your constructive cost model, that is Cocomo model, gives you two values. One, it gives you the effort in terms of person months, okay, and second, it gives you person months. Again, I told you, if it's 1 person months, that means one person working for 5 days a week and 8 hours a day will, so that's how many hours? So let's say, so he works, so if I have an estimate of 1 PM, so 1 PM means, so we have one person working for 5 days a week. So in a month he works for 20 days and every day he works for 8 hours. So it is actually 160 hours of effort. Okay, I hope it is clear now. If you have a doubt, please ask me again. I'll be more than happy to explain this. So one person month means one person working for 1 month. So when we talk about 1 month, we're not working like 24 hours a day. We are working for 8 hours, Monday to Friday. Okay, so that's how the client is also billed. So that translates to around 160 hours. So one person month translates to 160 hours of effort. So if you have 10 person months, that means you need 1600 hours. Okay, so whatever effort you find out from here, you have to substitute in the formula here, and that will give you the total development time. So in this case, we have these as constants. So 2.5 for all three, organic, semi-detached or embedded. Here it was different. For organic it was 2.4, for semi-detached it was 3, and for embedded it was 3.6. But these values are different. Like in this case also they were different, 1.05, 1.12 and 1.2. Here you have 0.38, 0.35 and 0.32. Okay, so whatever value comes out, that's going to be in months. So let's take an example. So suppose this is a problem specification. The size of an organic product, so we know it's an organic software product, has been estimated as 32 lines of source code. So 32 lines means 32 kilo lines of code. Kilo is divided by 1000, right? 1 kilogram is 1000 grams. So when you have 32,000 lines of code, you have to find out this in kilo lines of code. Okay, remember that the formula says, if you go back and have a look at it, the formula is given in KLOC. That's kilo lines of code. Okay, so 32 lines of code, you convert it into kilo lines of code, and then you can substitute it in this equation. So just remember that you have to find it in kilo lines of code. So in this case, 32 is what I have found out. So you for the organic software, what is the formula? 2.4 effort, it's 2.4 into kilo lines of code to the power 1.05. So you substitute all the values here, you get 91. Now 91 means 91 person months. Okay, so you can calculate in terms of hours also here. So that's basically 91 person months. So you need 91 people working for 5 days a week, and every day he works for 8 hours. Then if you multiply all this, you'll get in total number of hours. And then what is the development time? So in exactly what's the time required to make this project? So the time required to make this project will be, again, you take this 91, put it inside this equation and use the constant 2.5, and for embedded, this is organic, so for organic it is 0.38, so 91 to the power, so this is 2.5 into 91 to the power 0.38. So use your calculator to compute this and you will get a number 14, which means that in order to make this project, the development time estimate is going to be 14 months. Okay, so with 91 people working on this project, it will take 14 months. Now you can talk to the customer and you can reduce the nominal development time. So if the customer says, no, I want it within 1 year, I don't want it within 14 months, I want it within 12 months, then you can think about increasing the number of people. But the cost can be found out by, the cost of the product can be found from the effort which is required. Okay, so basically just keep this in mind. Just remember these three equations and formulas, although they are not going to be asked anyway around, because the focus here is software engineering. But in case they ask, or if something like this comes up, you can easily find out the effort and the nominal development time. Okay, so with this we can close your entire course on software engineering, and although this is not a very important chapter, you can just give it a read. Try this for the knowledge and for information that what are the activities which are required in project management and how basically they find out the cost and the effort and the time that is required for developing a project. So please go through this chapter, right? And all the best for your exams. I'll be taking 2 quizzes and I'll give you the link for them soon. I haven't been keeping well, so I haven't been able to take your online classes, so I thought I'll just make this video whenever I feel a little better. So please go through these videos, and if you have any queries or doubts, please raise it in the group. I will take an extra class. I'm planning anyway to take one additional class for you. Okay, so just share all the doubts that you have before your exams. I'll clear them all. Alright, so just go through this video, and then I'll talk to you on WhatsApp, and just let me know if you need me to explain things once again. I'll be more than happy to. Alright then, see you. Bye.